You are welcome once again to physics class today. I believe you've been able to understudy to go over the previous class on vertical projection. Without wasting our time, we'll be looking at the second type of projection, and that is our horizontal projection. Yes, when we see horizontal projection, let's take notes. This is our more y-axis, and this represents the x-axis. So a body is projected horizontally, and then we see the body coming to the ground this way. The velocity with which the body has been released is the horizontal component of u. Take note, most textbooks will just put it as u, but that u is for horizontal component of initial speed. Don't forget u represents initial speed. Having said that, from the height where the body has been released to the ground, that is our h, we can actually also determine the horizontal distance from the foot of the building or the cliff to that place where the body strikes or hits the ground. And that is what we call our range. R stands for range, and that is also the horizontal distance. So let's establish relationship between all these variables that we have put in place. Now, from equation 2 of motion under gravity or vertical projection, motion under gravity, we know that S is equals to ut. This time around the body is coming down, so our g will carry plus rgt squared. So if this S becomes our h, that is height, whenever we are talking about vertical, the u there is vertical component of u. And because we only have horizontal component of u, vertical component of u is always 0. Take note of that. Now, this becomes h is equals to uyt plus rgt squared. And that will give us 0 into bracket t plus rgt squared. If we move these two to the side of h, we are going to have 2h is equal to gt squared. By making t squared the subject of the formula, I have 2h all over g. So if I make my t eventually as the subject of the formula, that will give me 2h all over g. This is the formula for calculating time in horizontal projection. Take note of that. Don't forget, if it is vertical projection, our t is u all over g, and the u there is u subscript y. But here, to determine time in horizontal projection, we make use of square root of 2h all over g. Having said that, let us establish expression even for our h, for our r. Now, from, let me say, to determine r, using the same equation 2 of motion under gravity. So that same equation says S is equals to ut, because the body is coming down, g will still carry plus, we still put plus here. As I told us the other time, if this x is now our r, which is horizontal, automatically the u in question will be the horizontal component of u. And I told us earlier that in horizontal projection, g is always 0. G is for a body that is thrown up or body that is coming down. So this equation can be expressed as r is equal to ust plus 1 all over 2. Don't forget our g is now 0, t squared. So that this thing will become ust. But we have obtained t to be square root of 2h all over g, so that my r here can now be u subscript s square root of 2h all over g. This is the formula for calculating horizontal distance or our range. Take note of that. Aside these two, we may also have an instance where we be asked to determine velocity with which the body strikes the ground. Or the question may say just before the body strikes the ground. Let's say somewhere around there, we are asked to determine the velocity. When you have a point and you want to determine velocity, then it is important for us to draw a tangent to that point. Tangent to that point there will be my velocity, and because the body is coming down, that is v. If you look at this v, cannot call this v horizontal, neither can we call it vertical. It is important for us to determine the horizontal component of v. So this will give me that, where this one will be my vertical component of v, and this one will be my horizontal component of v. Now, to determine velocity with which a body hits the ground. And that is our V. When you have a drawing like this, don't forget this is angle 90 degrees. To get this V, we need Pythagoras theorem to produce that answer. So my V here, using Pythagoras theorem, I will have V square is equals to Vs square plus Vy square, and then V will become square root of Vs square plus Vy square. But this same Vs in question is equals to Us minus Gt, but your G is equals to 0, so that our Vx will now become what? Only Us. Also, my V subscript y will be Uy minus what? Gt. I told us that the body is released with horizontal component of initial speed. Our Uy will be 0. The Uy here will be 0. And from there, you can see there that Vy automatically will now be what? Minus Gt. If we fix the value of Vs and Vy into the expression of our V will now become V will be equals to square root of my Vs is now Us square plus my Vy minus Gt, everything square. So V will be equals to square root of Us square plus, when you square minus, that will give us plus. That will be G square T square. Take note. Let's solve one or two examples to really apply the equation. Let's solve one or two examples. Yes, I'll just extract the given. I don't have the time now to start writing the questions on the board. I will extract the given data. From there, we now solve for the required. Now, question says, a body is projected horizontally from the top of a vertical cliff, 40 meter high. Given example, given h to be equals to 40 meter with a velocity of 20 meter per second, that is our u subscript s, horizontal component of initial speed, 20 meter per second. Now the question is, we are to determine time taken for the body to fall to the ground. We are looking now for required we are looking for t. T is an unknown, and likewise, we are looking for the horizontal distance. That is our range. So, analysis. From the formula of t, don't forget t is equal to square root of 2h all over g. So if you substitute the value of h and g, whenever you are given a question and the value of g is not stated, use your g to be 10. That will be 2 times 40 divided by 10, 0. That will give us square root of 8. And that will give us square root of 8. Square root of 8. Root 8, that is 2.83 seconds. Now, for our second unknown, which is our horizontal distance, that is just UST. So you know your US already, that is 20, and we have obtained the value of T, 2.83. Then our R will be equal to that is 56.6. Don't forget, range is meter. Take note of that. Let's have one more example that has to do with velocity with which the body strikes the ground. Okay, yes. The question says, a stone is thrown horizontally with a velocity of 15 meters per second. Let's make use of this side. A stone is thrown with a velocity of 15 meters per second. A stone is thrown with a velocity of 15 meters per second. Given example 2. Given u subscript s to be 15 meters per second, and then we are also giving the height to be, our h is also given to be 100 meters. Then don't forget, even if you don't know g, our g is 10 meters per second square. The question wants us to look for the velocity with which the body strikes the ground, and that is our v. Analysis. V is equal to square root of Vs squared plus Vy squared. And I've told us the outcome of this is square root of Us squared plus G squared T squared. If we look at our given value, we don't know our T yet, but there's a formula that relates T and height together. And that is square root of 2h all over G. And that will give us what? Square root of 2 times 100 all over 10. 0 cancel 0, and that will be root 20 seconds. So let me leave it like that in root form. Therefore, so besides, let me make t squared the subject of the formula. So my t squared here will be what? 20 seconds. Second square. Take note of that. Hence, my v is equal to square root of the value of our u subscript s is what? 15. We square that plus our g 10 square times our t square. Here is what? T square is what? 20. Take note of that. And that will give us square root of 15 square is 225 plus 10 square is 100. 100 times 20. That will give us square root of 225 plus 2000. 2000. Take note. And then v will be square root of 2225. And that will give us square root of 2225. Give us square root of 2225. It gives us 47.17 unit is meter per second. We have finally come to the end of today's class. We consider the third type of projectile motion, which is our parabolic projection, in our next class. On this note, we have come to the end of today's class. Happy listening.